Hello everyone, I am Dr. Jagadha, Associate Professor in the Department of Mathematics. The topic for discussion is problems on Lagrangia's linear equation. We will discuss about the definition of Lagrangia's linear equation and problems based on Lagrangia's linear equation. The Lagrangia's linear equation, that is a linear partial differential equation of order 1. That is, if you are taking dou z by dou x, it is there. It is, the order is 1 and the degree also which is 1. Which involves, that is the partial differential equation which involves dependent variable. Here the z is playing the role dependent and two independent variables. So the two independent variables, that is x and y, of the form, here we can say it pp plus qq equal to r, where this p, q, r, they are the functions of x, y, z, which is called Lagrangia's linear equation. So, the Lagrangia's linear equation, whatever the given question, first we have to check whether which is in the format of this pp plus qq, which is equal to r, and where the p, q, r, they are defined as the functions of dependent and independent variables. Among the variables, the three variables, what we have, x, y, z, in which x and y, they are playing the role independent, z is playing the role dependent. Now, the Lagrangia's linear equation, which is solved by two methods. They are, the first method is method of grouping. The second one is method of multipliers. So the first, the given problem, we will be checking whether it is in Lagrange's linear format. Then we can adopt any method, whether it is method of grouping or method of multipliers. So the first problem, what we are going to solve now, which is solve z of z square plus xy into px minus qy, which is equal to x power 4. This first, the given question, which is not in the format of Lagrange's linear equation. That is pp plus qq equal to r. That format, first our given question, it is not. So we have to modify our question to the format of Lagrange's linear equation. That is, our given equation is, here we can see that is z of z square plus xy into px minus qy, which is equal to x power 4. Here, some changes we did, because our aim is, we want the Lagrangia's linear equation format, we want it, that is pp plus qq equal to r. To bring this format purpose, we are modifying the question. So to modify the question, first the z we are taking inside. So z into z square, it's nothing but z cube, and z into xy, that is xyz, Here we are noticing px minus qy, which is equal to x power 4. Again, this z cube we are taking inside. Z cube into px, z cube px, z cube into minus qy, minus z cube qy, and plus xyz into px. We can notice it, x is there, so x square. So put together, after multiplying px square yz, the next one, this and this, xyz minus into minus qy. It's nothing but minus q xy square z, which is equal to x power 4. Still, after we removed the brackets, still it is not in the format of pp plus qq, which is equal to r. So now this is the last step we obtained. The red color, which is colored the term, that is to make our understanding easy purpose, which is colored. In the both the terms, p, x, z is common, these variables. So we can see it, the common one where I am taking, we put it outside. So in this, after taking p, x, z as common out, the remaining one is z square. Here the remaining one is xy. So these two terms, simplification is over, and where I am putting the tick, these two terms z, q, y is common. So we can see it, y, z, q we have taken out. So here the balanced one is z square. Here the balanced one is xy. The right hand side, x power 4, which is written as it is. Now, so the given equation is xz of, here we can see it, xz of z square plus xy of p minus yz of z square plus xy of q, which is equal to x power 4. Now, our given question we modified and we obtained the result in such a way to satisfy the condition of linear equation, that is Lagrangia's linear equation condition, which is satisfied. So P is there, this term what I am circling, that is capital P. This entire one what I am circling is capital Q. This is playing the role of capital R. So that is the reason which is in the form of Lagrangia's linear equation PP plus QQ, which is equal to R, where we can see the capital P, which we circled it. We have given the name capital P, which is equal to xz of z square plus xy, and this is capital Q. So minus yz of z square plus xy, and this is playing the role capital R equal to x power 4. So the Lagrangia's auxiliary equations are, so dx by capital P, dy by capital Q, dz by capital R. So dx by capital P, dy by capital Q, dz by capital R. This we are naming as equation 1. Now we are going to take first two members. That is We know it to solve the Lagrange's linear equation. There are two methods. There is method of grouping. Another one is method of multipliers. Here we are going to use method of grouping, for which we have taken the first two members. So the first two members, yes, we have taken. We are noticing this one, the term is common, so it is getting cancelled. And Z also common, it is getting cancelled. Cancelled in the sense, this we are bringing to this side, so getting cancelled. So the leftover is the left position dx by x, which is written here. The right side dy by minus y. So we are going to do integration. So the integrating the left side dx by x, after integrating we obtained log x, whereas the right side position after integrating minus log y, the constant to be added, but both the terms are in logarithm. So log c1, which is added, all the terms are in logarithmic. So next, here we can say it, the left position is log x, the right position minus log y, which is there, that we are bringing to the left side. So it has become positive. So the left position log a plus log b, the logarithmic formula, we can write log of ab. According to that, we have written here log of xy, which is equal to log c1. Fine. So xy equal to c1, that we are naming as equation 2. Now, this is our total 3 members. First, we simplified, just now we obtained xy equal to c1. Now we are going to take among the 3 members, the first and the last member we are going to take. So we have done the cross multiplication. So after doing the cross multiplication, x power 4 dx, which is equal to xz of z square plus xy dz. Now this x we are bringing this side. So x power 4 by x, which is equal to x cube. Only this x is coming. Remaining as it is, we have written. Now using 2. Because we are noticing this we have to simplify. We have to do the integration. The integration, we have to be very comfortable. In an easy manner, we have to do the integration. So that is, here it's very simple one. Whereas here, 3 variables are there. But xy equal to c1, just now we obtained one result. So better we can replace this xy by c1. That's what using 2 which is written. This is our equation 2, what we named it. So completely here we will write a c1. Then we are very comfortable for the integration. Just like the variable subrable, that is x variables under one side, now z variable under one side, we can do the easy integration, that is integral x power n dx. It's nothing but x power n plus 1 by n plus 1. So this is the last step, what we obtained it. So we did the simplifications before doing the integration. That is left side, there is no change at all. Whereas coming to the right side, z into z square, it is z cube, z into c1, z c1 dz. Now we will apply the integration. So the integration x cube, that is x power n, Our n is playing the role 3. N plus 1, 4. So x power 4 by 4, which is equal to our z cube. 3 plus 1 by 3 plus 1. Fine, we completed the integration. Whereas coming to the picture of here, z power 1, 1 plus 1 by 1 plus 1. Z square by 2, C1. The constant we added, that is plus b. So we can see very well x power 4 and z power 4. We can take the LCM. Here 2 is there. So taking LCM, it is multiplied by 2. And here also we can see it completely taking. Here 4 should come. 4b. That is x power 4. This z power 4 we are bringing to the left position. This is also we are bringing to the left position. That is minus 2z square c1, which is equal to 4b. So completely the left side, there is no changes at all. Whereas 4b, because already the first one what we simplified, we named it as c1. Better this 4b, we will name it as c2. Mathematically it is correct. So here we can see it. That is x power 4 minus z power 4, 2z square c1. That is nothing but xy. We introduced that is in the place of xy c1 because to do the integration in a very easy manner. Just now we completed the integration, then xy, that is c1 which is replaced by xy. So the general solution is pi of, so the first c1 equal to xy we obtained. So the next one is x power 4 minus z power 4 minus 2z square xy, which is equal to 0. So completely the first problem, we finished it. So we will move to the second problem, which is p of x plus y plus q of sine of x plus y equal to z. Looking at this only, the trigonometric terms are dominating. So the given equation is, we have written here, that is p into cos of x plus y plus q into sine of x plus y, which is equal to z, which is in the form of Lagrangia's linear equation. That is pp plus qq, which is equal to r, where our capital P equal to cos of x plus y, capital Q equal to sine of x plus y, capital R equal to z. So the Lagrangia's auxiliary equations are, we can see it dx by capital P, dy by capital Q, dz by capital R. So according to our equation, the P, Q and R, we are going to replace it. So we replaced it. After replacing, we obtained dx by cos of x plus y, which is equal to dy divided by sine of x plus y, which is equal to dz by z, and we named it as equation 1. Now to simplify, we are going to take the multipliers. That is, taking 1, 1, 0 as multipliers. That we can see the first one, which is up and down, it's multiplied by 1. So we obtained dx by cos of x plus y, that is multiplier. We have taken 1, 1, 0. That is, this is multiplied by 1, multiplied by 1. This is multiplied by 1, here multiplied 1, here 0 into 0. So such a way we have to do the multipliers. After multiplying, the third member is vanished. So the remaining we obtained dx by cos of x plus y, which is equal to dy divided by sine of x plus y. So both we are going to do the addition, numerator as well as the denominator. So we obtained dx plus dy divided by this both we added cos of x plus y plus sine of x plus y. So now this one result we obtained, just we are keeping aside. Next, the equation. Now the multipliers we have taken 1 comma minus 1 comma 0. Before we have taken 1 comma 1 comma 0, here only the change, the middle one is minus 1. So we know it. This is 1, 1. This is 1 minus 1. This both we are adding the numerator and denominator. So when we are adding the numerator, we obtained dx minus dy divided by cos of x plus y minus sine of x plus y. So this result, we can see it, this result and this result, both to be equated to our third member. Our third member is dz by z. So the completely we are naming as equation 2. So we can see the equation 2. Now more to do the simplification, that is our x plus y we are assuming as t. And here the both the side we are doing the differentiation, that is dx plus dy which is equal to dt. That is, we can see it here, that we are going to substitute in our equation 2. First, this we will concentrate. dz by z equal to dt. That is the upper one, we can write it d of x plus y. This one. So x plus y, it's nothing but t. So dt divided by cos t plus sin t. This in a simplified format we have put it. Cos t. Here we can write it. It won't affect the sum. That is root 2 sin 45, we know it, 1 by root 2 cos t plus cos 45 1 by root 2 sin t. So we are taking this root 2 inside. So after taking the root 2 inside, we obtained cos t plus sin t. So if you are cross-checking, we obtained the previous result. So it is not affecting at all. And we are noticing this complete the format. It is in trigonometric. The formula. That is sine of a plus b, which is equal to sine a cos b plus cos a sin b. So ours is sine of a plus b. So t plus pi by 4. And this root 2, we brought it to the left position. So root 2 into dz by z, which is equal to dt by sine of t plus pi by 4. So we can write the 1 by sine, it's nothing but cosec. We have written integrating. So root 2, this integration is log z. And this integration of cosec, log turn off this t plus pi by 4 into 1 by 2 plus the constant we added. Both the terms are in logarithmic, so log c1. Next, the simplification part. What we have done it. Here we can notice it. Actually the same step which is repeated. Now, this log a is there. Suppose m is there. We can write m log a. Log a power m we can write. Using that concept, using that formula, here which is written, here we can notice it. Z power. Here also actually log should be there. Log of That is, we can write this log of z power root 2. And this is log a plus log b. We can write log of this term into this term. Log getting cancelled. This we obtained it. So now this turn we are the trigonometric term we brought it. So 1 by turn theta, that is 1 by turn of 1 by 2, which is nothing but cot, which is equal to C1. So more simplifications. T what we assumed it, that is x plus y equal to t, that is t which is replaced by x plus y. So this is our equation 2. These two we simplified, some result we obtained it. Now what we are going to do, we are going to take this and this. Anything we can take, we have to simplify the integration in an easy manner which is equal to some constant. That we have to do the result. Next, these two, here we brought it, this term to the left position. We can see it here. That is cos of x plus y minus sine of x plus y. We brought to the left position into dx plus dy, which is equal to dx minus dy. So now what we are going to do, the previous simplifications what we assumed it, x plus y equal to t, that is cos t minus sine t divided by cos t plus sine t. This is d of x plus y, that is dt, which is equal to dx minus dy. So we can see it here. So integrating on both sides. Now we will do the integration. We can see it. So now this integration, to do it, cos t, the integration is minus sine t. The integration one, very simple one, that is, suppose here f of x is there, the top f dash x is there, we can write a log of f of x. That formula we are going to use. For that, we can check it. Cos t, the differentiation is minus sine. Sine t, the differentiation is cos t. Exactly it fits this formula. So after integration, this is the result we obtained it. Dx integral is x, dy integral is y, minus is as it is minus, plus log C2. So now this result, the left position, only the log C2 from right to left position we brought it, that is minus log C2, which is equal to x minus y. Now this is log A minus log B. We can write it log of A by B. So log of A by B, which is equal to x minus y. This is in logarithmic form. Now we will write it in exponential form. That is cos t plus sine t divided by C2, which is equal to e power x minus y. So we can see it here. Next, this C2 we push to right side. Finally, we obtained cos t plus sine t, which is equal to C2 into e power x minus y. We need C2 equal to that format. For that, this we brought it to next this side. When we are pushing to the exponential term to the position changing, then x minus y, it has become sign changing, y minus x, which is equal to C2. So this is the result we obtained it. The t what we assumed it, that is x plus y, which is equal to t. So cos of x plus y plus sine of x plus y into e power y minus x, which is equal to C2. So the general solution is, we can write f of or pi of, that is, this is the one C1, this is C2, what we obtained the solutions. That is z power root 2 cot of 1 by 2 of x plus y plus pi by 4, comma, cos of x plus y plus sine of x plus y, the whole into e power y minus x, which is equal to 0. This is the general solution of our given equation. So we will move to the next problem, that is solve the partial differential equation. A very simple problem, that is z of x minus y, which is equal to px square minus qy square. So we are going to compare the given equation with our Lagrange's linear equation formula, that is pp plus qq, which is equal to r. Looking at the question itself, easily we can tell it fits to our Lagrange's linear equation, because small p is there, this is capital P, this is capital Q, this is capital R. Exactly, it fits our Lagrange's linear equation. So the capital P, which is nothing but x square, capital Q, which is nothing but minus y square, capital R, which is equal to z of x minus y. So now the auxiliary equations are dx by capital P, dy by capital Q, dz by capital R. So the P, which is replaced by x square, Q, which is replaced by minus y square, R, which is replaced by z of x minus y. So everything we replaced it. 3 members we got it. The first member, second member, third member. Among the 3 members, we have to get 2 solutions from which we have to derive the general solution. So what we are going to do, a very simple one, we are going to take the first and second member, that is where I am putting the tick. So we selected the first and second member. We will do the integration. The integration part, x power minus 2 dx, which is, we can write it 1 by x square as x power minus 2 dx. So x power minus 2 plus 1 divided by minus 2 plus 1. It's nothing but x power minus 1 by minus 1. So we can notice it here. The result is this minus, it has come up. X power minus 1, it's nothing but 1 by x. Same similar manner now, y power minus 2 dx is nothing but minus 1 by y, but already minus is there. That's what the result is, positive. So we added the constant, that is plus c. So we obtained that 1 by y from right position to, we brought it to the left position. That is minus 1 by x minus 1 by y, which is equal to constant. So both the sides, the minus sign, we push it to right side. It has become 1 by x plus 1 by y. It's nothing but minus c. So minus c, we can name it as c1. So the solution is 1 by x plus 1 by y, which is equal to constant, that is c1. Next, we are going to take our first and second member. This is the member. We have added the numerator and denominator. We obtained dx plus dy divided by x square minus y square. So, this a square minus b square formula, so which is written a plus b, a minus b. Here our a and b are x and y. So the first and second member we added and we applied the a square minus b square formula. Now we are going to equate, this is the result what we obtained, to our third member. Our third member, which is here. Now this we are noticing left and right, this term is common, getting cancelled. After cancellation, the left side is dz by z, whereas coming to the right side, dx plus dy by x plus y. So dx plus dy, which can be written as d of x plus y. Integrating the left, both the sides, we are integrating. The left side, the integration is log z. That is integral of dz by z, it's nothing but log z. Here also we can notice it. The down one is x plus y in the denominator. The up one, which has the differentiation. Then we can write log of the term. That is log of x plus y and the constant which is added in logarithmic form. Just we brought the log of x plus y towards the left position, we obtained log z minus log of x plus y, which is equal to log z. So now, this is in the format of logarithmic formula, that is log a minus log b, which is equal to log z. We can write the logarithmic formula, log a minus log b, which is equal to log of a by b, equal to log c2. Both the sides we can cancel the log. Then we obtained z by x plus y, which is equal to constant. So the general solution is, this is the result we obtained, c1 equal to 1 by x plus 1 by y. Just now this we obtained c2 equal to z by x plus y. So the general solution is pi of 1 by x plus 1 by y, comma, z by x plus y, which is equal to 0. So now we will move to the next problem, that is solve. Here we can notice it, z square minus 2yz minus y square of p plus xy plus zx of q, which is equal to xy minus zx. Whether it is in the format of Lagrange's linear equation, yes, it is there. That is this complete one, which is in the format of Lagrange's linear equation, that is PP QQ, which is equal to R. Exactly, it is matching with our Lagrange's linear equation. When it is small p, this is playing the role of capital P. This is small q, this is playing the role of capital Q, and this right side is nothing but capital R. So the given equation is, just we have written our equation, that is z square minus 2yz minus y square of p plus xy plus zx of q, which is equal to xy minus zx, which is in the form of Lagrange's linear equation. That is pp plus qq, which is equal to r. So now we can see here our capital P equal to z square minus 2yz minus y square, and capital Q is xy plus zx, and capital R equal to xy minus zx. So the Lagrangian's auxiliary equations are, so we know it very well, there is a formula dx by capital P, which is equal to dy by capital Q equal to dz by capital R. So the capital P, we replaced it by z square minus 2yz minus y square, which we obtained from our equation, and dy by capital Q, that is xy plus zx. Finally, the capital R is xy minus zx. Now, we obtained three members, we obtained it. Among the three members, we have to do the simplifications and we have to obtain the results, for which we have taken the multipliers, that is x, y, z. On what basis we selected these multipliers? X, Y, Z. So here up and down, which is multiplied by X. The second member, which is multiplied by up and down Y. The third member, we are multiplying by Z. This is the way we have to do the multipliers multiplication. But there is a doubt on what basis we selected these multipliers. That is, the selection to be after multiplying, we are going to do the addition numerator and denominator. When we do the addition of the denominator, the result we have to get compulsory 0. On that basis, these multipliers are selected. So we can see it, the multiplication is completed. So here x dx, and here x is there, we are taking inside xz square, and here we are taking minus 2xyz. Here we are taking xy square. So it is completed the first member, the work which is completed. The second one is y. So up and down we multiplied by y. So the y we are taking inside. X into xy into y, xy square. Zx into y, zxy, which is equal to. So now this z here, z. So z dz by xyz minus z square x. Now, what is that? The condition of the Lagrange's multiplier. After multiplying the multipliers, we have to add the numerator as well as denominator. But after adding the denominator result should be 0. So we can see it. What I am circling, these both are getting cancelled. They are in opposite signs. Next, these both are getting cancelled. Minus xy square plus xy square. Whereas here coming to the point, here we can see zxy is there. Here also zxy and 2xyz. Here minus 2xyz. They are getting cancelled completely. Our denominator is vanished. The result is 0. We have to get it. We must get. Here the result is 0. Then only it is fit for what we selected. The multipliers are correct. So x dx plus y dy plus z dz divided by 0. So now we are going to do the integration. That is the integrating x dx plus y dy plus dz. So x power is 1. We know the simple integration. X power n, which is nothing but x power n plus 1 by n plus 1. Our n is 1. So 1 plus 1 divided by 1 plus 1, x square by 2. The same here also, y power 1, y square by 2. Here z square by 2, which is equal to some constant, that is a. We have taken the LCM, just the 2, we brought it to the right position, to a. So x square plus y square plus z square, which is equal to c1. Next, we are taking from our question our second and third terms. That is, this is our second member, here our third member. So when we are comparing the second and third member, in the second and third member, the term x is common, here also x is common. So that they are getting cancelled. After cancelling the common variable x, we obtained dy by y plus z, which is equal to dz by y minus z. Now we will do the integration. Before that, what is the result which is kept here? Just we did the cross multiplication. Dy into y minus z, which is equal to dz of y plus z. Y into dy, we obtained y dy. Z into dy, z dy, and y into d is z, y d is z, z into d is z, z d is z. Simplifications part, y dy as it is minus z dy as it is. This y dz, we brought it to the left position. It has become minus y dz, and this is also completely one left position we brought it. So plus z dz also minus z dz, which is equal to 0. Now the term which is common, that is we have taken, because we are going to do the integration to make our integration very easy manner. For that, this work we have done it, that is y dz plus dz dy. We can write it in a simple form, the differentiation, the derivative of yz. This, what I'm circling, we didn't bring any changes, just they are written as it is. Now our integration is very easy manner. That is, here we can say it y dy. That integration is, we know it, y power 1. That is 1 plus 1, y square by 2. And here the integral we are doing, integral differentiation, getting cancelled, yz. Here the integral z power 1, that is z square by 2, which is equal to constant. So we are taking the LCM. So y square minus 2yz minus z square, 2 we brought it to the right side, 2b. Already we obtained a result, C1 equal to the solution which is equal to C1. Now we want to the format of the solution which is equal to C2. Mathematically, this constant what we obtained 2b, we can write it as C2. It is correct. So the general solution is pi of x square plus y square plus z square, that is C1, and y square minus 2yz minus z square, which is equal to 0. This is nothing but our C2. So we will come to a conclusion of this topic, problems on Lagrangian's linear equation. Method of grouping, under which we discussed about it. Solve z of z square plus xy of px minus qy, which is equal to x power 4. First, looking at the question itself, it is not under satisfying the formula of Lagrange's linear equation, because it should be pp plus qq equal to r. First, we modified the question to bring the format of Lagrange's linear equation, and the members what we obtained, then we solved it. Finally, two results we obtained it, C1 equal to xy and C2 equal to x power 4 minus z power 4 minus 2z square xy, which is equal to 0. The next problem, we obtained z of x minus y, which is equal to px square minus qy square. Then we obtained the result. Here, method of grouping, that is among the three members, any two members we can select. We selected two solutions we obtained. This is C1 equal to 1 by x plus 1 by y. This is C2 equal to z by x plus y. The general solution is pi of 1 by x plus 1 by y, comma, z by x plus y equal to 0. So under method of grouping, we discussed two problems. Next, method of multipliers. Yeah, very difficult. That is a trigonometric term containing the problem we selected. P into cos of x plus y plus q into sine of x plus y, which is equal to z. We solved it. We obtained the general solution. Then solve one more problem under method of multipliers we did, that is z square minus 2yz minus y square of p plus xy plus zx of q, which is equal to xy minus zx. This is we treated as capital P, this is capital Q and capital R, and we substituted in Lagrangia's auxiliary equations, dx by capital P equal to dy by capital Q, which is equal to dz by capital R, and we did the simplifications, that is method of multipliers taking, and we completed. The solutions what we obtained is pi of x square plus y square plus z square, comma, y square minus 2yz minus z square equal to 0. Thank you very much to you all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.